Welcome, my students. Now, our discussion is regarding Newton's second law of motion. Newton's second law of motion, rate of change of momentum is directly proportional to the applied force, and the change takes place in the direction in which the force acts. From this law, we will obtain the measurement of force, that will be F equal to m into a mass into acceleration. This is obtained from Newton's second law of motion. F equal to ma. From the first law, what we obtained? From the first law, we obtained the definition of force mass, and secondly, we obtained the definition of inertia. Definition, qualitative definition, was obtained from first law. Now, from second law, we will get the measurement of force. That is, quantitative definition also will be obtained from second law of motion. What is stated in second law? Second law stated that the quantity of force which is applied on a body is directly proportional to the rate of change of momentum. Force is proportional to the rate of change of momentum. Rate of change of momentum. This is the mathematical expression of the second law of motion. Now we will establish the equation F equal to ma, that is, quantity of force is equal to the product of mass and acceleration. For this, we can take a body which is moving with velocity m. Let us consider a body whose initial velocity is u. Initial velocity equal to u, and after an interval of time t, after time t, the final velocity becomes v. Mass of the body equal to, say, m. And its acceleration, let be f. Now the initial momentum of the body, initial momentum equal to momentum equal to mass into velocity. Initial momentum equal to mass into initial velocity u. So m into u, that is equal to mu. Final momentum equal to mass into final velocity v, that is equal to mv. Now what is the time taken for this change of momentum? T. So in time t, change of momentum equal to mv minus mu. Initial momentum was the mu, and final momentum mv. Say initial momentum was 10 and final momentum 15. So the change of momentum is 15 minus 10. Here mv minus mu. And for this change of momentum, an interval of time t is taken. So in unit time, the change of momentum, that is rate of change of momentum, that is the change of momentum in unit time, rate of change of momentum equal to mv minus mu, that is m into v minus u divided by t, that is equal to m into a, because v minus u by t equal to acceleration a, as v minus u by t equal to acceleration a. So rate of change of momentum is ma. Initially we stated from the second law of motion that force F is proportional to rate of change of momentum, that is F proportional to ma, or F equal to K into ma, where K is a constant of proportionality. K is a constant. This K is called constant of proportionality. Therefore, we have obtained F equal to K into ma. If unit force, unit force is defined as the quantity of force which acting on a mass of unit, that is unit mass, to yield unit acceleration, that is F equal to 1, m equal to 1, a equal to 1. Again stating that if unit force is defined as the quantity of force which acting on a body of unit mass can generate unit acceleration, then it becomes 1 equal to k into 1 into 1, or k equal to 1. And if k equal to 1, then F equal to 1 into ma, that is F equal to ma. So force equal to mass into acceleration. It is the most important formula. Force F equal to ma. Keep in your mind. Thank you, my students. Now we have discussed about the second law of motion. Then after we will go through the numericals. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.